Hello, class. So this is the final video covering section 3.7. I believe we last left off with problem 36, where we simply just type log 3/4 and press a button and we get an answer. So I'd like to move on to problem 39. And I'm going to actually switch documents and show you a document that's already completed. So bear with me. So problem 39 asks us to solve the equation by estimating a solution, solving graphically, and then using logs or logarithms. So here's the problem. 10 to the x equals 150. So we're trying to figure out what value of x would result in 150. So if I put in a 2 for x, well, 10 to the 2 is 100. That's too small. I need 150. So if I replace x with 3, I end up with 10 times 10 times 10, which is 1,000. Well, that's too big. So the value of x that will result in 150 is going to be somewhere between 2 and 3, okay? And you might even say probably closer to 3 since, closer to 2, right? Because 150 is closer to 100, right? If I were to ask you, is 150 closer to 100 or 1,000, you'd say 150 is closer to 100. So the value of x will be between 2 and 3, probably closer to 2. So that's us solving this by estimation. What about graphing? Well, we can graph both sides of the equation. Okay, so the left side of the equation is 10 to the x. The right side is 150. So if I take out my calculator and do y equals, we clear out whatever's in here, and I'll put in 10 raised to the x for y1 and 150 for y2. And remember, there's going to be a straight line at 150. So if I go to my window, go from 0 to 10, and I just need some number that's bigger than 150. I'll use 200. I press graph, and the intersection should be my answer. And remember, we're expecting the answer to be between 2 and 3, closer to 2. I press second, trace, 5, enter 3 times, and you'll notice I get x is 2.17. So ask yourself, is 2.17 between 2 and 3 closer to 2? And the answer is yes, it is. Okay, so that's us solving the same problem by graphing. Next, we're going to say, well, let's solve the problem using logarithms. So remember, we learned that we can rewrite an exponential function as a logarithmic function. So remember, the base of my exponent is 10, so the base of my log is 10. So I write log base 10. The exponents will be free, and we bring in the 150. So I can write log base 10 of 150, and our calculator is in base 10. So I can simply just enter log of 150. Right, so if I press second mode to get out, and I press log 150, and then press enter, 2.17, which is the same answer we had when we did graphing, okay? 2.17. So that's 39. Number 40 is similar, right? There's really not much new here. Again, if I'm going to do an estimate, I say, okay, what value of x is going to give me 275? I'm sorry, what value of x is going to result in 725? Well, if I replace x with 2, that's 100. If I replace x with 3, I get 1,000. So 725 is closer to 1,000. So again, my answer is going to be between 2 and 3, probably closer to 3, right? Because 725 is closer to 1,000. So let's prove it. Let's graph this thing, right? Go back to y equals. We already have 10 to the x and y1. y2 we changed to 725. Now my window has to change, right? My y max is stopping at 200. So let's make it 1,000. Oops, I'm in the wrong area. Go down to y max. We put in 1,000 or enter 1,000. We graph. Again, we expect our answer is going to be between 2 and 3, except this time closer to 3, because 725 is closer to 1,000. Second, trace 5, enter, 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 2.86. Again, ask yourself, so is 2.86 between 2 and 3 closer to 3? Yeah, sure is. So on a test, if you're going to solve this graphically, you give me a rough sketch. Not going to be a Mona Lisa, but a rough sketch will do. Now using logs, again, I can rewrite this in logarithmic form. The base of my exponent is 10, the base of my log is 10. The exponent is what we free. The 725 comes inside, so you can simply just enter log of 725 in your calculator. Oops, I hit the wrong button. There we go. And we press enter. 2.86, which is the same answer we had from graphing. Right? And the last one is really the same, except this is a bit tricky. Right? Notice on the first two, we had 150, 725, big numbers. And now we have 0.85, a real small number. So if I enter 10 to the 2, like we did the last two times, I get 100. Well, 100 is way too big. We need 0.85. If I put in a 1, we get 10. Too big. I put in a 0, we get 1. All right, that 1's getting closer. What about a negative 1? Right? 10 to the negative 1 is the same as 1 over 10, or 0.1. So 0.85 is in between 1 and 0.1. I'm sorry. 0.85 is between 1 and 0.1, but the value of x that will give me 0.85, or the value of x that will result in 0.85, is between 0 and negative 1. Okay? And if we were to graph this, well, same thing. You're going to graph y1 is 10 to the x, and y2 is 0.85. Okay? Now the window's a little tricky here, because here we're going to have a vertical, a horizontal line at 0.85. So we're going to really just tighten up our window here. I'm going to go from -5 to 5, and -5 to 5 again. And once we have our window, I will graph it. Now, if you're having a tough time with the window, remember, you can solve this problem using logs. And there's our horizontal line at 0.85. We press second, trace 5, enter, 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 and you see it's at 0.07058 would be the intersection. So I tried to sketch that as best I could. Okay, and it was negative, right? Negative 0.07058. And it looks like I rounded. Okay. So that was number 41. And then again, if we want to solve this using logs, right, we could do the same thing that we did for problems 39 and 40. I can simply type log 0.85 and press enter, and -0.0706, right, which is what we have here. Okay, I hope that helps. Thank you for watching. Just going to scroll up so you can just see the answers one more time. Okay, great.